Okay, so now what we are going to look at is how to do this graphically. So as you can see, the equation that I have here looks a lot more complicated than the x to the third and the polynomial we were looking at. So some of the problems that they give you in your book look a lot harder than they are to make sure you fully understand the methods of graphing rather than giving you an easy equation. So there are two ways to do this. And method one is to find the zeros, just like we just did on the other page. But no, you want to do this one algebraically. There is no nice way to do this algebraically. So to find the zeros, what you have to do, and you should be writing this in your notes, is to set one side equal to 0. Now for here, what I would do is I would take one side, doesn't matter which side, and I would move it to the other. To move it to the other, I need to do the opposite. Well, this is plus 3, so I'm just going to subtract 3. When things are long like this, what I recommend, or even longer, is to make sure you use parentheses. Parentheses would help. So I would do minus, took this hand side, so let's call it the left-hand side. I took the left-hand side, and I'm going to subtract the right-hand side. And I'm going to use parentheses over the whole right side because my graphing calculator understands order of operations and understands things when I have parentheses. So now I moved it over and it is equal to 0. So in a minute we will look at Desmos and we will look at what we're finding. So here, if I set it equal to 0, I'm going to be looking at my graph for the zeros. Your graphic calculator would do this too. Last year when you started learning the graphing calculator, you learned how to find zeros. Method 2, on the other hand, and we're going to look at both on Desmos in a second. I might have to have two videos. I'm hoping not. But method 2 is to find the intersection. And again, the method itself is telling you what you are finding. So here I'm going to call y1 the left-hand side. And I would say that would be the absolute. I don't know how to do the absolute in this Google Doc, so we're going to do it like this. Y1 would be x minus 4, the absolute of x minus 4. And y2, and we'll look at Desmos for this method as well, would be 3 on the square root of x minus 2. And again, as I said, the method is telling you what you would find. So in my graph, I would have an absolute. Remember how an absolute looks. And on the other slides, I showed you what a radical looks like. It's going to look something like a rainbow. And I'm going to figure out where they cross. Whereas this one is going to make a whole new function, which I'm not even sure how it's going to look. And we'll look at it together in Desmos. And then you would find your zeros. Okay. So here, intersection, remember for those of you who can't remember, this would be point where they meet. Okay, here, your zeros are where the graph crosses, well, I should say where the function crosses the x-axis. So pause this video, make sure you have all this written down. Now I'm going to go over to Desmos and we're going to look at how this looks on Desmos. And if I get stopped in the middle, I will have two videos for this. Okay, so now I look at Desmos and I'm going to go back, sorry. And what you could do here is you can look at your keyboard tab and under functions, you could go through these and look for absolute. Sometimes it's easy to find, sometimes you can't. I could not find this example, but what's nice about Desmos absolute is actually right here now that I saw it. But if you didn't see that absolute was right there, is you could write absolute and then it does it for you. So this would be x minus 4, or, and I'm going to show you how it's the same thing. You hit the absolute down here and do x minus 4. So even when you can't see things in Desmos, it does it for you, which is really nice. So on the next video, I'm going to pick up right where we're at because we're going to have to add the rest of this equation. But I will see you back on the next video.